Okay, so we're going to go beyond simple enumeration types such as color and rank. Color and suit were the enumeration types that we looked at. We're going to define in a moment a rank, and a rank we're going to give an example of something which is a little bit more involved than a simple enumeration type. But before we do that, I just note something that may come in handy later. An alternative notation for these kind of pattern matching definitions that we've been using in this form. They're a little bit repetitive because we name the color function over and over again. There is an expression level way of writing this, and that is to use a case analysis. So this is how we might write the first version that we wrote using a case analysis. Now this is useful, in particular useful when we need to actually do an analysis of some function of an input. For example, if we wanted to have a function which worked on the suit but did so depending on the color of the suit. We can't pattern match on the color of the suit directly. We have to apply the color function to do that. And so if we have a case analysis, then we can do a case analysis on the color of the suit. And if it's a red card, we do one thing, and a black card, we do something else. So that's a little bit of alternative notation. There's also some handy information here about what happens when you have incomplete patterns. Consider this definition here. You may think that that's just the same as the definition I've written over on the right-hand window, but actually it isn't. It's slightly different. It's different because we've actually in this line here misspelled the word color. Now, does that make it invalid Haskell? Actually not. This is the definition of two functions, one called color and one called couleur. And the color function does something with spades and something with clubs. And the couleur function, whatever your argument you give it, it gives you back red. Now, clearly this is not what intended, but what would happen with this definition is you wouldn't catch this error until you actually run the code and try to apply the color function to a red card. For example, the color of diamonds, it would give you an exception. And it would say non-exhaustive patterns in function color. So that's a tricky error to spot. You may not have spotted it when you glanced at this. It's possible to set an extra warning flag in GHCI to warn you of incomplete patterns. So this missing patterns and also missing signatures could be another useful warning to look at. So then if we load a file with this set, then actually the compiler will give us a warning that there's missing cases in the definition of color, and that would probably help us find this bug that we've introduced a new equation for a new function, which has nothing to do with the old one. Okay, let's get back to the main thrust, and that was to move from defining a suit to defining a rank. And the reason is here because a playing card contains a suit and a rank. So we're going to define a data type for suits, a data type for a rank, and then we'll combine them into a data type for cards. And then finally we'll combine them all together into a data type for a hand of cards. So a rank then is representing the value of the card. Here I've listed the four enumeration kinds, Jack, Queen, King and Ace, in ascending order of importance. But there's also the numeric cards. Now there are various ways of defining this. One way would be to define new constructors for each of the numeric cards. For example, we could have a numeric 2, a numeric 3, and so on, and we could keep defining these until we have enough values. So we introduce one constructor for each numeric card. This would introduce a data type which would be very precise. We precisely model everything we want, but the cost would be that it would be quite a big data type. We're going to use a different way of defining the numeric cards. And the way we're going to do it is to introduce a constructor that contains data. We're going to have a numeric constructor containing an int. So here's so this is the format that we're going to use. So let me explain what this means. This is introducing a new type, called a rank. And this rank is being defined by 1, 2, 3, 4, 5 different constructors. But this constructor is a function, and it takes as its argument an int. So in order to build a rank, we need to apply this constructor to some int. So for example, Jack is a rank, and numeric 2 is also a rank. So we ask, what is the type of numeric 2? Well, it says it's not in scope. Let me reload that file that I've just edited. The type of a numeric 2 is also a rank. So now we can write our numeric cards as, for example, numeric 10 is one of the playing cards. So this is introducing something beyond just an enumeration type. It's a constructor that contains some data. So you can think of a numeric card contains some additional data, and int to tell you what the value of its card.